It's like I'm on TV.
It is like that, except you two.
Yeah. It's like two people watching. Hello, person. Can you hear me? Sweet.
Sure, well, I just did introduce them.
All right.
All right, well, welcome, everyone. Thank you so much for coming to today, the July meeting of the Salt Lake City MR user group. I imagine that most of you found us through our meetup.com page, but just be aware that we are there and organizing there and announcing our activities and meetups and whatnot. Today we are really lucky to have Andrew Heiss here to talk to us. Andrew is a professor at BYU and is going to be talking to us about data visualization using R. And then next month we have another great speaker, and we're going to be hearing about building APIs in R using the Plumber package. And I'm really excited for that as well. So it'll come back out in August. And then September is when we're doing Bayesian intro to Bayes. Is that right? September? Yeah. So in September we're going to do intro to Bayesian analysis. So we've got some really interesting stuff coming out. So with that, we will give Andrew plenty of time to talk to us. So let's go ahead.
All right, cool. I'm excited to be here. This is really cool. I've never come to one of these, and it's like this amazing view. This is great. So yeah, as Julia said, I'm a professor down at BYU in the Romney Institute of Public Management. It's the part of the business school that does like government management and nonprofit stuff. So it's like an MBA that doesn't destroy the economy. Like it's a good version of an MBA. I finished my PhD at Duke last year in public policy, and so technically I'm like a political scientist, public policy guy. I look at international NGOs and authoritarianism, and that's kind of my world generally. But as I do that stuff, I do R for all of my cool stats things. And so that's what we're going to be talking about today is R. The quick plan for today, there's 4 little sections here. First, we'll talk about why we visualize data. I'm assuming you all know why, but we'll briefly talk about it. General types of visualizations. The bulk of this presentation, though, will be about aesthetics and design and why this is actually very important for data visualization in general. Graphic design is an important skill. You can't just use default R plots as easy as they are to make. They don't help communicate stuff very well. And then finally, we're going to, I have kind of a presentation up here. We're going to take a really boring R plot and make it awesome using this acronym, CRAP, which we'll be talking about here. And so we'll be able to make really cool, pretty things. The slides and all of the code and this giant list of cool resources and links to books and articles on data visualization is all here at this website. You don't have internet here, but when you do have internet, you can go there, and it'll be great. So make a note of that. So quickly, just to talk about my background a bit. As I said, I have a PhD in public policy. I do statsy quantitative stuff with data and with panel data based on countries, trying to predict when authoritarian regimes will kick out NGOs that work in their countries. But my original background was not in stats at all. My undergrad was in Arabic and Middle East studies, and I minored in graphic design. And so I worked a lot with web design and with print design especially. And so I was hired by BYU's Maxwell Institute for something. They do a whole bunch of religious books. Because I spoke Arabic, they put me in charge of typesetting Arabic, English, side-by-side translation stuff, which was cool, because I was doing like high-quality typesetting in a foreign language, and it looks really cool. And so the whole time I've been working on my PhD, other master's degrees, they've actually kept me hired on the side, and I still do academic print publishing, graphic design stuff while I'm doing my regular day job. And so I have lots of different projects, but I also do kind of nonprofit graphic design and stuff. So that's kind of my background there. I was introduced to the quantitative world of design When I was working on my master's in public administration at BYU, I had to take a stats class, and it was my first one ever, and I was terrified of stats. And we had to use JMP, which is made by SAS, and it's kind of like the baby version of SAS, and I hated it. Because it was really hard to use, and it made ugly graphs like this. There's no legend there, it's just dots, and that was all I could figure out how to do with JMP. And this was after years of doing graphic design, and like, this is ugly, and I couldn't change the fonts, and I hated it. That year, after I took this class, this book was published. And Nathan Yao published his Visualize This book. He worked formerly with the New York Times, Washington Post, and Wall Street Journal on their graphics teams, and kind of helped invent this new workflow for creating graphics for data journalism, where you do stuff in R, export it as a PDF, stick it in Illustrator, make it cool, and then publish it to the web or in a book or something. And when I realized you could do that, I got really excited. Like his first example here is this hot dog eating contest. This histogram there comes from R. It's a really basic, you just use base R, histogram, blah. It creates this ugly thing, but you put it in Illustrator and make it fancy. And that got me really excited, so I started using R and threw away JMP and rewrote all of my class notes from the JMP class into R, and have been doing R ever since, because you can make cool stuff with R. So that's kind of my background. Very graphic design heavy, but it's still very important to combine this graphic design stuff with kind of the quantitative actual data that is there. So first of all, why do we even care about this? Hardcore old school scientists often say, like, we don't need to look at pictures, just show me a chart with data. That's all I need to figure out. Just give me the t-statistic, I'll know if something's significant, the end. Or people can somehow interpret like interaction coefficients in regression tables. I don't know how they can do that. You have to plot it so you can actually see what's going on. Otherwise, like if you have a three-way interaction that has a cool significant coefficient, what does that even mean? Nobody knows. And so data alone cannot tell you the stories behind your theories or prove theories. If you just have a table, you're not going to get as much insight as you could by looking at the actual data. So many of you are probably familiar with this. This is called Anscombe's Quartet. It's 4 different data sets with 10 observations each. They all have the same sum, average, and standard deviation of 99, 9, and 3.3. So if you didn't ever look at this, you would say, cool, these distributions are equivalent, publish this paper, hooray. If you visualize them, though, they look like this. And so the relationship between those x and y variables are totally different, even though they have the same mean, standard deviation, and everything else. And so looking at the data, you realize, like, you could be in this world here trying to run a model predicting something, and you're always going to get 8, except once you get 18, and that might be an outlier. And so you could run this cool model that actually means nothing. There's a more modern version of this called the Dinosaurus, or the Datasaurus dozen, where they figured out, using cool algorithms, 12 different data sets that all equal, again, the same mean and standard deviation correlation coefficient between those 2 variables. So all of these different data sets are the same functionally at a summary statistic level. But unless you visualize it, you wouldn't know if you had an X or a dinosaur. So it's important to look at that. Beyond that, we are visual creatures by nature. There's this cool paper that came out a few years ago that argues that we are the best animals on the planet because we realized how we could like see predators really well, and we're good at pattern recognition. So when we were running through the jungles millions of years ago, we could see that and know that that's a cheetah, we should run away. Other animals would see that and say, cool, dots, and then they get eaten. And so we're really good at recognizing patterns. And so when we see patterns graphically, we can make intuitive guesses about what those patterns mean. Sometimes this can go into overdrive, and that's bad. It's a phenomenon called pareidolia, where you see things and you say, oh no, it's an angry green pepper. Or this is from the Discovery rover. A couple years ago, they found this woman standing on Mars, which is just a rock formation with a shadow, but it very clearly looks like a person on Mars. Or the surveillance camera ready to get you. So we see these patterns, we're like, oh, obviously, run away, this guy's going to get us. But this is because we're really, really good at seeing patterns. And so we should be able to visualize stuff way better than looking at tables. So if you've ever been to any sort of academic conference or anything academic gimmicky. This is the standard. This is a regression coefficient table. People will throw this up on the screen and say, thus we see that crackdowns on NGOs do bad things because of Model 5 right there. And that means nothing to the general audience, but also to me, who ran this model. I look at this and I'm like, yeah, what does that even mean? Instead of giving just the mean and the standard deviation there, this is from a Bayesian regression model, you can just plot them and you get the different coefficients. This right here is the same as this. This is just the graphical form of this. And this, you can get inferences a lot easier than just looking at this. And so it's easier to see the patterns. It's easy to see how close both of these models are. They basically overlap all over here, except there's kind of a little bit there, kind of a little bit there, but that's not significant. And so you see those patterns a lot better than just staring at a table for hours. Okay? So visualize data. We have cool eyes that let us see patterns, so look at the patterns. What makes a good visualization good? We can talk about this for like days. There are all sorts of principles. People have written books about it. The one principle I'm going to talk about right now, though, is the idea of cramming as much information in the plot as possible and interpretable. And so the canonical example of this is this plot, which you may have already seen in all data visualization talks. This is like contractually obligated to include this. Because Edward Tufte, who's like the grandfather of data visualization nowadays, has called this the greatest data visualization in history, which is really hyperbolic, but it is actually a really cool graph. There are 6 pieces of information, 6 variables in this picture here. This is from Napoleon's invasion of Russia in 1812, which is the War of 1812. Like the song with the cannons, it was written because of this, not because of the Canadians burning down the White House. Tchaikovsky didn't care about that. He was writing about this story where Napoleon invaded. He was here in Vilnius, which is Lithuania nowadays, and he invaded Moscow with a gigantic army of 422,000 people. But he did it in the middle of the winter. And so what this shows, the size of this river type thing here, is the number of troops in Napoleon's Grand Army. And so as they go from Vilnius to Moscow, notice how they lose 322,000 people, has the numbers here. So by the time they get to Moscow, they're down to like 100,000 troops. And then they have to come back because it's really cold and they're out of supplies. So they get back to Lithuania with 10,000 troops at the end. And so just looking at these 2 streams, you can see kind of the magnitude of how bad that invasion went. Everybody died. Like 90% of his grand army froze to death. You can actually see the freezing to death down here. This part here shows the temperature in reverse. And so this is the temperature in Celsius when they left Moscow, and then it starts dropping and dropping, and it was negative 30 degrees when they got to Molodeno here, and then it's negative 26 by the time they got back to Vilnius. So everybody like froze to death, and you can see that here. So the 6 types of variables you see here are the latitude and longitude. This is an actual map. You can see rivers. You could overlay this on like Google Maps, and this is actual like the arrows. You see direction. So the brown shows the direction going towards Moscow. Black shows going away from Moscow. You see troop size, which is the width of this area here, and you see temperature and dates. There are dates with each of those temperatures. So you get tons of information by looking at this. Which is really cool. And so Edward Tufte uses this example to kind of establish 5 characteristics of graphical excellence. The one we care about is here with number 3. It's the idea that whatever gives the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space is a good visualization. And so it's called the data to ink ratio, where the more data you can fit in a graph without wasting ink or having tons of empty space that's not showing anything, the better. And that makes better visualization. It's really easy to not do this, though, and we always forget to think about the data to ink ratio. So this is from an actual published paper, which is great because it means absolutely nothing. The only colors that matter are this blue 8.1%, which could be any of these blue ones. I don't know. Or this 21.8%, that's cool. That's other. So you're not conveying any information with this. This is useless. This is like destruction of the whole data to ink ratio. Don't ever do this bad. You can also get really cool and fancy. USA Today loves to do these dumb graphics. So right here, this is actually from NBC, it shows the changing demographics of America from 1960 to 2060. And apparently all the Asians will live in central Maine by 2060. And they moved from northern Washington, and then all the others will be in northern Maine. Like, this is crazy. Don't do this, first of all. It's also a waste of ink. This whole red space, what? Like, they could have done this way easier with just bar graphs or line graphs, something. Way better than this. This makes no sense. I don't know why this got published. It's great. Okay? So don't do that. Always think about the data to ink ratio. Okay? So, now a couple types of visualizations. There are generally two categories of visualizations that you deal with in your everyday life. You have exploratory visualizations, where this is where you just type plot X in R and look at the scatter plot and something is there or not. You never really present that to other people. You don't really care about other people consuming that in the public. It doesn't matter. It's just helping you analyze the data that's there. Then you have explanatory visualizations, which are the publishable things that show up in Vox and the New York Times and Washington Post, and those are really cool graphs. It's the Menard plot that we had there with the War of 1812. We like these things. So with exploratory data analysis, you've probably all run graphs like this. Yay, histogram. Helpful histogram. But using ggplot, you can actually bump up the data to ink ratio if you add a fill for a different categorical variable, and then you have like 3 histograms of different colors, and so you get more information. Or you can facet into like 4 different plots with 3 different categorical variables, and so you can get like 12 pieces of information in one plot just with 1 histogram. So you can do all sorts of stuff to kind of bump up that ratio. Same thing with density plots. You can overlay lots of density plots. But it's also helpful to just have like a super simple thing. But you would not publish this. Like, who cares? It's a mountain. So like with this, you have a scatter plot with points, but you can also put in colors for kind of the cylinders in these cars and whatever QSEC means. I don't know. Like, we all use this MT cars data set. No idea what's in it. So this variable, you can size the points by whatever QSEC is, and it shows you more information about kind of red cars, which have 4 cylinders, have higher QSEC and lower weight and higher miles per gallon. Story, whatever that means. Or you can do all sorts of things like violent plots with points factors on there, so you're just bumping up that data to ink ratio. Again, this would never show up in like the New York Times or Vox. Like, that's ugly. I would present it to like my advisors, and they'd be like, "Doesn't even make sense." And there's like blog posts nowadays, like a few months ago, one like decrying violin plots because they can look bad and give bad connotations of like human anatomy, and so there's like this movement away from these things. But they're helpful for seeing kind of the distribution of the different variables. So we like exploratory data analysis, but that's not where we should stop. We should move into the explanatory data analysis, where you annotate the graphs and you tell some sort of story with the graphs. So you see this all the time. Pew is really good at this. Washington Post is good at this. 538, they exist because of this, and Vox exists because of this. So again, these are just 6 density plots, but they've shaded them differently, and they have all sorts of annotations there, so it tells a story of the kind of the partisan shift in Congress since 1994. And you can spend lots of time looking at this. This has a very high data to ink ratio. Tufte would like this. And this is like, this tells more of a story than just like these things that let you see the data. Okay? So you want to live, when you talk to people about your project, you want to live in this world as much as possible. And this actually fits in kind of Hadley Wickham's tidy data analysis paradigm. This graph here, where you import your data, tidy it, do all this kind of stuff, and then communicate. In the end, both of those types of data visualizations live in this thing. So at this point, you're visualizing data, transforming stuff, modeling stuff. That's all the explanatory stuff, or the exploratory stuff. The explanatory stuff comes at the end where you communicate. So this is kind of a standard way of categorizing these 2 types of visualizations. There are a ton of resources out there about which kind of charts to use. because you can't, like if you have like a whole bunch of factors, you can't really do a density plot of factors. That doesn't work. Of like male and female, that doesn't have a density. And so there are tons of websites out there. In the talk page that I showed at the beginning, I also showed at the end, I linked to a bunch of them. This one's cool because it has like this decision tree. So if you have like 2 numerical variables and one is ordered, you should do this connected scatter plot or an area plot or whatever. It tells you all these different types of charts that you can do given the nature of your data. This website is cool because when you click on these, it shows actual R code and Python code for creating each of these, which is great. And this one too, also in that page that I've linked to, it shows how to create all of these different plots in like 40 different programs. It keeps going. And so you can get code for doing it in D3 or in Flourish, whatever that is, or in Amazon QuickSight for whoever uses that. So you can get code for making all these charts. So there's awesome resources out there for creating these things. OK, but making the explanatory graphs is hard because the exploratory ones where you just say plot x, comma, y, you get a cool scatter plot. But then you want to be able to communicate stuff about that data to other people in a way that they'll actually get something out of it instead of just looking at dots. And this is where graphic design is super important because this is how we communicate to other people in general. And Edward Tufte, as much as grandfatherly as he is in the data visualization world, he's also kind of the get off my lawn type of grandfather. Last week, he tweeted this screed, which has since been deleted, which was sad. I had to like find like the plain text version of it on somebody's website and fake the tweet here because it did exist. But he was yelling at the RStats community for making ugly graphs. And so because of that, tons of people started responding. Klaus Wilke is writing a book on data visualization, and so he publicly gave up. Like, I quit. Okay. Or there's this nihilist data scientist who also just advocated, with all other things in life, it's healthier to give up. Embrace your failure, for it is inevitable. So essentially, like, people were joking, and then there's this giant battle, and then he deleted all his stuff. And people were trying to prove to him that you can make cool graphs that have great annotations, that have great graphic design principles in them with R. Kieran Healy is also writing a book on data visualization, and he did this giant blog post explaining how Tufte is wrong and how you should use R graphics properly, and there's still room for doing Illustrator and the stuff that Tufte was complaining about. And so we're going to talk about that really quick. Because as much as kind of this was angry and mean, he might be right to some extent. Okay? Because when you make a plot, like, that's ugly. If Edward Tufte is just thinking about this, yes, don't do this. And he complained about a Stanford stats book. I have that stats book. And the plots don't all look like this, but they basically do. They're very, very simple, which, again, the scope of the book is just teaching stats and R to students. But it's not trying to communicate stuff. But you can still make that look a lot prettier. And you can communicate better stuff. Also, something Tufte was complaining about was the typography and the general design in R graphs. R cannot do everything. For example, these 4 sets of numbers all use the same font. This is Minion Pro. But notice how they are different. All 4 of these things have different number shapes. You have proportional old-style numbers. So notice how the 3 goes below the baseline of the 2, and the top of the 6, the ascender of the 6, is above the top of the 7. This is great for numbers that are inside text because it flows just like a lowercase p or an uppercase h. You get the same ascenders, and so it feels like letter forms rather than just numbers. But you wouldn't want to use this in like a table showing data because then it's harder to follow it. So you can use tabular numbers down here. Notice how these are all the same width. And so if this is in a table, you can actually read straight down from like all the 5s or all the decimal points at that point. Here, the 6 and the 6 are no longer aligned. And so if you're using numbers like that, the table is all distorted. Same thing happens in graphs. If you try to, like, R by default uses this kind. And there is no way that I have discovered, and I've tried, to use any of the other letter forms that are in OpenType fonts. It's not possible. The only way to get that into graphs is to export a graph, put it in InDesign or Illustrator, and then manually change the OpenType settings so that it uses proportional old-style figures or something like that, which is cool. But if you're trying to do this reproducible project, you have to redo that every time you run your R Markdown file because it wipes out all the changes you make, and that's not great. Same thing with ligatures. One really cool thing that fine typography does. Notice the FFL and the TH down on this bottom line, they're all connected. Or the FFI, the dot of the I is actually part of the F there. And that looks really nice, and that's a sign of good typography. Next time you look at a book, see if they're using ligatures, and then you can judge the designer on how well they did. R will do this, and Word does this, and other programs that don't care about ligatures. And it gets kind of ugly there. The top of the F and the L crash, and you get this weird triangle thing there. And so it's not great typographic standards. There's no way in R that I've discovered yet to turn on ligatures inside annotations or inside access text or anything like that. Again, if you want that, put it in Illustrator or InDesign, turn them on, and then don't run your R Markdown file ever again, or else you have to do it again. Okay? So there's still a place for that. But R can do a lot of the harder work in annotating and creating all of this great stuff. So that flowing data book that I showed you at the beginning with the hot dog eating contest, the only part that was made in R back in 2011 when that book came out was just the bars in the histogram, and you did everything else in Illustrator. Nowadays, you can do pretty much all of that graph in ggplot, or base R if you really feel like it. And if you want the finer typography, then export it to Illustrator, turn on the ligatures, do stuff with numbers, make it look cool, and then you're good. But you can do lots of the hard work in R nowadays. And so this was Kieran Healy's main point in the whole Tufty kerfuffle here, where his book, which is free online, but Princeton University Press is publishing it, it follows very fine typographic standards. There's ligatures in all of the plots, and everything looks great. The only way that worked, though, is he has a super well-done manuscript, but the typographers at Princeton University Press still had to do stuff to the page layout, and still had to do the finer typography, the finer graphic design, which Edward Tufte was complaining about doesn't exist in R, which, fine, it doesn't. But you still get lots of the hard work done without moving everything to InDesign or Illustrator. Okay? So we keep talking about this idea of good design. What does that mean? How do you recognize, if you look at a poster in a hallway, if we walked outside right now, there's a bulletin board there, and there's lots of flyers, and I guarantee 90% of them are super ugly, and you also recognize that. So how do we know if something is ugly beyond just intuition? There are core graphic design principles that you can use to judge the ugliness or the non-ugliness or the utility of something that is designed. The best, easiest summary of these graphic design principles is this book here. It's called The Non-Designer's Design Book. It's fantastic because it covers these principles and it has you kind of do exercises to fix flyers and fix posters that are really ugly. It also has sections on typography, on how to properly kern text and add additional tracking and deal with baselines and do all sorts of cool typographic things. I highly recommend this. It's made for people who are non-graphic designers. And all of your stuff, I guarantee, after you do stuff in this book, even if you make just a regular flyer for your neighborhood, it will look so much cooler than just Times New Roman centered, bold heading up at the top, hit enter a whole bunch of times to space stuff out. You don't have to do that. And this teaches you how. But the really cool part about this book is there are 4 easy to remember graphic design principles that are kind of like a checklist that you can use looking at anything to the design to make sure that it's there and that it's communicating something. So those 4 principles are contrast, repetition, alignment, and proximity, which make a cool acronym that's easy to remember. Okay? CRAP, which is the opposite of actual crap. So as long as something that is designed has these 4 elements to it, it will generally look good and help communicate the story better. And so we'll talk about each of these four and show some examples. I'll get some sort of cool contrast in the design. You can do contrast with type. This is fairly easy to do. There are different type families. There's serif fonts, which have these little thingies sticking out of the end of the letter forms called serifs. You have sans serif letter forms, which are out serif. And so like the L has this little thing up there, but it's there. Using these two together is a good way of getting contrast. You can have sans serif headings, serif body text. The next time you look at a book that has headings in it, most likely it'll have sans serif headings, or if not, it'll have like super dark serif headings that are the same font as the regular body font, just to get that contrast in there. You have slab serif, which are like serif, but like with these big wanted poster type, like giant edges. You have script fonts. You have decorative fonts. Even within the same font family, you can have different weights. So we're used to like font weights, pentad, or do all sorts of mathematical stuff to get a good color palette that has good contrast in it. Color Brewer was designed for maps so that it's clear, like no two adjoining colors look too close, and so there's good contrast there. So there's all sorts of cool palettes that you can download there. There's an R package for using Color Brewer palettes directly in like a ggplot. The cool thing nowadays, though, because of science, is to create these perceptually uniform color palettes that are really good for people who are colorblind or have other difficulties in looking at contrast. And so this is the Viridis package. Don't know how to say it. Guessing it's Viridis, which is now the default in ggplot for creating color panels. And so rather than having like a rainbow, red and blue and green and yellow and orange and whatever, it uses this scale here. And so if you have a discrete plot, it'll pick points along this panel here that are perceptually, like mathematically different from each other. And so it creates a good contrasting color panel that is really easy to interpret. And you have all of these different color, like these spectrums inside the Viridis package. There's this other one called the Scientific Color Maps project, which does the same thing as Viridis, just with a whole bunch of different things. And there's a new R package called Psycho, good name, for accessing these in ggplot. And so you can, instead of just using the Viridis ones, you can use these cool ones like La Jolla or Bilbao or Oslo or whatever, and get the same kind of better contrasting color palettes into your plots or into your designs in general. Okay, so color is another place where you can add contrast. So an example of this in real life, this comes from the son of the author of this graphic design for non-designers book. This was his resume originally. This is the updated version using only principles of contrast. And so notice the headings are no longer all caps Times New Roman bold with a colon. They use this fancy sans serif font, but then the text uses a lighter serif font, and then it has bolded sections here explaining like the actual job position, web designer and developer, which is bold, but also sans serif, and then the rest is serif. And so you get lots of contrast in there, and it generally looks a lot nicer than this. Like if I were hiring this guy, I would hire this guy, not this guy. That's because I'm biased against like Times New Roman. But just adding contrast in there improves the design a lot. Okay, the R is repetition. You want to repeat elements of the design throughout the design. And so a good example of this is this old flyer that I took a picture of at BYU. So this is in 2004. This is a very old picture. There are all sorts of repeated elements in here. There's the repeated orange. It's the same Jamba Juice orange throughout. All the drop caps are repeated, so the Y and the E and the J. It's not repeated here, but that's because that's the main story. And so rather than get a drop cap, it just has a bigger kind of introductory paragraph that is bold, but that same bold introductory paragraph is repeated there and there and there. The lighter orange background is repeated. This fruit that's in the background is repeated throughout. This oval shape around the pictures is also repeated and kind of matches their swirl. So like every element on here has some other piece of it being repeated elsewhere, either the color or the shape or the feel or the weight of the font. And so it looks very well designed because it has that repetition throughout. Okay, so this is important too. Like if you have like a book and you have headings, use the same font for all of your headings. Don't switch to a different sans serif font every time you have a heading just because it's cool. Like that breaks the principle of repetition. Alignment, everything on the page should be aligned with something else on the page, which is fairly simple. So like you have this graphic here. Beyond alignment, it looks okay. Like you have this bolder, heavier font there, and then this lighter font, so you have contrast there. But everything's just kind of floating around. If you took a ruler and drew all of the lines that things are aligned to, you have a line here by E. You have a line here. You have a left aligned line there, and there, and there. So you have like 6 different left alignments, which is great. You also have a bunch of top alignments. You have this one, and that one, and that one, and nothing's really fitting. All you have to do to fix this to make it like pop is that. Nothing else changed except the position of the boxes, and now they're all aligned with each other, and everything now is either like left aligned here or top aligned there, and it looks a lot nicer just having that there. This is one of the cardinal sins in ugly graphic design. You've all seen things like this. This has 2 different alignments in it. It has a centered alignment here, but then it switches to left down here. Why? I don't know. Centering is generally not a very strong alignment anyway. You should try to avoid it if you want to make stuff look cool, unless you have everything centered and you're trying to go for like a fine artsy type piece. But if you had this like right aligned and big and everything else left aligned with like a contrasting big font there, that would look a lot better. Or this. How many different alignments are here? You have this H, which is not aligned with that H, which is not aligned with that, which is over here. This is aligned to the right of this box, but not down there. The bottom of this could almost be aligned with the bottom of that thing, but it's not. And so just reshuffling stuff on there would look a lot better. Or the alignment inside this box, the tortilla soup is not like centered in the box. So like bring that up or something. It looks like it was accidental. And so as long as you make sure everything is aligned on the page, you should be good. Proximity is probably the easiest part. Just group related items together. So an example of this is like this business card here. It's cool because it's for this mermaid tavern. That's very clear it's for here. But what's the phone number? Like you look there. What's the address? Like it's hard to kind of follow the flow of this business card. Nothing's really grouped together well. All you have to do is rearrange stuff like this. Everything's the same font size, same font, everything. It's just this is now up here and that's now down there. It makes a lot more sense. So that's proximity. Okay, so in summary, you have contrast. So notice the contrast here, different fonts. So this is a serif font, sans serif font, this black background with the white text, and then the black text. Like that's good contrast there. You have repetition. So it has these little gray arrows or gray triangles that are repeated throughout. The same serif font is used down here, same sans serif font used down there, repetition. Alignment, everything has a very strong alignment. You could also like left align this and that would look okay because you have contrasting alignment. They actually like nest inside each other here. And that would look better. If you had one thing centered, one thing right, one thing left, that's not a very strong alignment, and it breaks repetition too, because you're not repeating the same alignment. And then proximity, just group things that should be together. Okay? So now you are all like super dangerous graphic designers because you know this much and you can make cool stuff. But I'd highly recommend getting that book and working through it because you can make your ugly stuff. If you've ever made anything like this, which I guarantee you all have, even if it was like in high school or middle school, like this is easy to do in Word. Don't do this. Spend a little bit of extra time making stuff like this, applying these graphic design principles. And it's a helpful acronym because you can look at a design and then think, is contrast working here? Yes. Is repetition? Yes, because they're repeating this, repeating the alignment. Is alignment working? Yes. Is proximity working? Yes. And so if you go through that checklist, then you're good. If something's broken, fix it. Okay. So now we're going to apply those same principles to R to make Edward Tufte happy. Because in general, default R graphics, both in base R and in ggplot, violate lots of the principles of CRAP. So this plot right here, how many different alignments are there? There's one centered. So this is good, like the title and the axis thing or the axis label are aligned, but you have another centered line right here horizontally. But it's not necessarily right in the middle of all the axis tick marks. Sometimes those are scooted around, sometimes those are scooted around. It's really hard to have like strong alignment when everything's centered because there's nowhere to like anchor stuff to, which is why centering is not like the greatest alignment in general. ggplot does the same thing. With ggplot version 2 that came out last year, the default for title position actually moved to the left, probably because people were complaining about always having to move stuff away from center. But even so, the default ggplot theme nowadays will have multiple alignments. So the title and subtitle, if you add those to a plot, are left aligned. The axis labels or axis titles are centered. If you add a caption, it goes down here in the right. So you have 3 different alignments in one plot, which you probably shouldn't do. Especially when, like, if you moved everything to the right and kept the caption at the left, that's better. Because you have 2 strong alignments. But if you have like a weak centered alignment plus the other 2 strong ones, that's not the greatest. So you can use the theme function in ggplot to make all sorts of modifications to these plots to make them more crappy. And you can actually put all of these adjustments and tweaks inside your own theme function. So you don't have to always, like every time you make a ggplot, you don't have to say left align the title, left align the caption. It simplifies it for you. You can also do all of this in base R if you really want. I don't know how, because ggplot's paradigm is great. So what we're going to do for the last part of this is walk through some code about how to take a boring ggplot graphic and make all of these different theme changes to make it look a lot better, including fonts, including colors, embedding the fonts correctly, exporting PDFs and PNGs that are publication ready. They could go into an InDesign document in a newspaper. They could go into a PNG that's ready to be uploaded at Vox, whatever. Okay? So we'll just quickly step through some code here so you can see this. OK, so this is actually our Markdown file that is up online. Like, you have all of these different books and articles and stuff, so you can see that later. What we care about, though, is making some pictures. So we're going to load some packages. Apparently jump way down there. Cool. OK, so again, like default R stuff, once it decides to run, stop. There. So the default R plot is ugly because it doesn't have a lot of contrast. It has some, I guess. Like, that's bold. That's not bold. Contrast. But it has bad alignment, not very strong contrast. And so we can do stuff to fix it. ggplot does the same thing, but we didn't load ggplot. Why not? Okay. Yeah. There we go. So there's the boring ggplot thing. And again, the caption down there is right aligned. That's left aligned. That's centered. You have 3 different alignments going on there. OK? So what we're going to do is use some data from the Harry Potter character API, which I just discovered yesterday. And so it has all sorts of cool data about the names of all of the named students and professors in the book. It's all characters, actually, but I shrink it down so it's just people at Hogwarts. Has their house, has the school they work at, has all sorts of other stuff, like are they in the Order of the Phoenix? Do they work for the Ministry of Magic? Are they in Dumbledore's army? Etc. It's really cool. So what we're going to do is look at the distribution of characters by student or professor status in the 4 different houses in Harry Potter. So this, again, goes beyond the point of this presentation here. But this is just using dplyr stuff to clean the data and extract just professors and students and summarize it. And so we have this count of professors based on houses and a number, and then students, houses, and a number. OK? And all this code is online, so you can look at it. So here's the basic. Didn't load ggstance. OK, so ggstance is cool because it lets you do horizontal bar charts. OK. So here's the basic ugly default graph. Cool. You get some insight there. That's a good exploratory graph. You wouldn't want to publish that on Vox or whatever. But it does show you that like most of the characters in Harry Potter are students in Gryffindor, which makes sense because Harry Potter himself is in Gryffindor, and the whole story is revolved around him. And Ravenclaw is like the second most, so maybe there's the relationship between those two houses, possibly. We can write a paper about it. And we don't know, like professors are mostly Gryffindor and Ravenclaw, and we don't know a lot about others. There are only a few Slytherin. There's only one Hufflepuff professor, which falls into that whole meme of the Hufflepuffs being kind of daft. So sure. Okay, but we want to fix this chart because that is kind of ugly default. We want to make it more crap-y. So what we can do is fix some of the alignment here. So if you look at the code here, I add a couple additional things inside theme. So I take the strip text, which is these caption or these facet titles there. I can make them left aligned. I can make the caption left aligned, and I can add extra space in between those two panels, because this right here, the scale x continuous expand equals 0, 0. What that does, notice how there's this weird space between the edge of the plot and the beginning of the bar. We can actually move that all the way out, so it's right next to the label, and that's what that expand 0, 0 thing does. And that helps with alignment. The main issue with that is notice how the G and the A are aligned with the plot, but they're not aligned with the bars. And so you have two different left alignments. If we move that over, then you'll have one strong left alignment there. So it's a tiny tweak, but it actually helps it look a lot nicer. So if we do those tweaks, look at that. Everything's now left aligned or right aligned with one single line. The bars go all the way to the edges, and that looks a bit better with alignment. We can get rid of some of these extra things like the axis ticks. We don't really need because we know that's Slytherin. We don't need a little tick showing us that that's that. We also don't need these horizontal lines because we can see that like that's Hufflepuff. You don't need to keep going. So we can get rid of some of these extra things. So we can add a few other theme options here. So getting rid of the ticks, getting rid of some of the axis grid lines, and that gets us to this point. So now we only have one grid line, which is this vertical one, which is good because it's repeating that same strong line that we have here that everything is aligned to, but we still have the same kind of feel, that vertical feel that is repeated throughout. And so it kind of feels better than the original ugly graphic. Okay? So notice how we have like all of these theme options, and that's awful. Because every time we want to make a graph, we don't want to keep repeating that. And so what we can do is put all of this stuff in our own custom theme that we can then repeat. The way I like to do this best is to make a function that is just a wrapper around some sort of new theme. So I base it on theme black and white, which is one of the built-in ggplot themes. And then I make all of these adjustments here. And then I return this new theme. And the nice thing about doing that is instead of doing like theme black and white or theme minimal or theme any of the built-in ggplot themes, I have theme Harry Potter, which has all of those options in. I didn't run it though. Silly R. There. Okay, so that's my new theme Harry Potter there. And then any plot I make from now on, I can just use theme HP, and it works. ggplot has kind of a built-in way you're supposed to do that with this weird replace thing. But I don't like doing that because you can do other fancy things inside the function here. You have more flexibility as a function. So I actually do this for every project I do. I make my own custom theme for the project, probably because like of the design background. Sometimes it's super simple. So like this one project on public service motivation that I'm working on. All I do is just the minimal theme with this font. And I have this argument for changing the base size. So it's basically just theme minimal with roboto condensed. That's all it is. But later I can change stuff. For this project here, this is a bigger one. This is a project on NGOs. I have an argument here for density, where if I'm plotting density plots, I want it to be slightly different than plots without the density plot. And so here, when I'm adding like, kind of the density figures there, I want to get rid of all of the grid lines and do stuff with the text. And so when I actually run this in the plot, I say theme NGOs, but then as an argument, I say density equals true, which you can't do with like if you do the fancy replace thing that ggplot has built in, because it's only supposed to work with like the theme as it is. So this lets you do fancier things. Same thing here, like on some graphs, I want to have an access line on the bottom and the side. Sometimes I don't, and so I have an option there down here where I will either have it or not. And so then I can enable that in the function. And you can do all sorts of cool stuff there. So that's why I like doing this rather than whatever this is. I can never get that to work. This is easier. OK, so there's our theme. We can do colors. Right now, there's no contrast in the colors. It's just all gray and black. So there are lots of different ways to specify colors in ggplot. You can have like a named list, which is this right here. I found these at some like 13-year-old girl's blog from 2016. She made palettes for each of the houses. So cool. The cool thing about doing the named list is if I want to access like red or Gryffindor's, there's Gryffindor's color, and if I run that, then I get the hex code for Gryffindor. And so I do that sometimes, like here. I actually don't use a named list. I just have variables with those, and so I just use them as they are. I'm not consistent with this at all. I have this right here that's just a vector that's not named. I hate doing this. Don't do this, because you never remember what they are. Like this makes sense because it's black, whatever. But if you don't have them like as actual English names, you have to like comment and remember what everything is, and it's awful. And so if you have like a named list, you can name the colors, and it's a lot better. And so if I add scale fill manual and add those colors there, then it will map the right colors to the right bars, and it's great. This did not come from like a perceptually scientific color scheme. This is just what J.K. Rowling invented. But you can also use like scale Viridis or scale Psycho or whatever and get better kind of perceptually distinguished graphics. Fonts. This is Edward Tufte's biggest thing, because this is Arial, and Arial's ugly. It's a ripoff of Helvetica, and so don't use Arial. The tricky part about using fonts, though, is that it's hard to embed them. It's easy to use them inside themes in ggplot. All the built-in themes have a base family argument, and you can type kind of the family name, and it'll use it. But then if you want to get that out into a PDF, everything breaks. And so what I do here is I take that Harry Potter theme, and I expand it to specify fonts for the title and the subtitle and the caption, and the different, like the geom text and the geom label. Those don't pick up different, like you can't change theme stuff to get the stuff that you plot. So you have to do this thing. And so what this lets us do is get typographic contrast. And so the title is going to be in Code Sans semi-bold. The subtitle is going to be in Code Sans light, because we want that typographic contrast there. We want to repeat that light font in the caption, and then we want to repeat the strip text as semi-bold. So we're getting the repetition in there too. And so what this lets us do is it will suddenly look like this. Ha. OK, so we have strong alignment here. We have everything's kind of vertically oriented here. But then we have the semi-bold, and we have the light that is repeated, and we have this extra note that also uses light. And so it kind of matches the principles of crap that we have going on there. Just by moving stuff around and changing fonts a little bit, that looks a lot better than the original ugly ggplot default from theme gray. OK, so finally, this is easy to do, and you can just take a screenshot of that and put it on a blog or whatever. But if you want to submit that to a journal or put it in a report that is being made in InDesign, and you want the actual vector version of it, you have to save this as a PDF. When you do that, though, ggsave is the normal way you save things as PDF. And if you run it, it will yell at you, because ggsave by default only works with like Arial and Times New Roman, and that's like all. It doesn't know how to embed fonts in PDFs. And so if we look at that PDF that it made, it's beautiful because it will look like that. Yeah. Okay? That's not good. Don't publish that. So what you can do instead is there's a graphics library that's part of Linux, but you can also install it in Mac and Windows. Nowadays, it's automatically installed with Mac and Windows R. So when you install R, you get Cairo for free. If you specify the plotting device inside ggplot as Cairo PDF, it will embed the font. And that works. And then if we look at it, houses with fonts. There's our PDF with the embedded fonts. Yay. Okay, so it's just that minor change. Just use the Cairo plotting library instead of whatever R uses, and you get fonts automatically. PNGs are also easy to make with ggsave. You just change the PDF to PNG, and it automatically does stuff behind the scenes to make it work. You can specify the resolution of your graphics. So if you want a high resolution graphic to go on a website, or if you have to publish a non-vector version, like if you're using Word can't really handle PDFs very well, so you want like a high resolution PNG. When you drag that into Word from just the basic ggsave, it actually does not respect the dimensions of whatever you specify. So here we saved it as 4 inches by 7 inches, but if you look at the top here, that's like 9 inches wide. It just fills up the whole thing. So if you're knitting a document, it'll take up the full size. So if you have like a really small plot, it's going to blow it up. Sometimes it even goes off the page, and it's awful, and it's infuriating. But you can get around that, again, with Cairo. If you use the Cairo graphics library, it will create a PNG that actually respects the dimensions and the resolution that you tell it to. And so when you put that inside Word, that's the correct size. And so you can knit things using the Cairo PNG library, and everything will be right when you knit to Word or knit to PowerPoint or whatever. And makes your life happier. So use Cairo. It fixes everything for you, and lets you do this cooler graphic design stuff that I don't know, Edward Tufte would probably not approve of this anyway, because that's way too thick there, and it should just be like little dots, because that's what he does. But this looks like you could publish that on some like Harry Potter forum or something. It looks better than the ggplot, the original thing that we had. Okay? So you can do all of this graphic design stuff with R, which is exciting. So the moral of the story here, now that you know some basic graphic design principles, you can make those tweaks. Doing stuff with graphics is very important because that's how we get insight. We're designed to look at patterns, like that's why we have eyes. So we don't get eaten, but also so we can see relationships in our data. Using graphic design principles makes it easier to understand the graphics that we see and the patterns in society. Beyond just graphics, like anything that is well designed should have these 4 principles in it at least. And so anything you make from now on, try to stick contrast, repetition, alignment, proximity, and make sure those things are there. And then finally, you can do tons of this well-designed stuff with R and ggplot, modifying the theme, making your own themes, and then you'll have prettier things in the end and be able to communicate stuff a lot better. Okay, so that's what I have on graphic design in R. So make pretty stuff. There's the URL.
Again, awesome. We have a couple of questions. I know there's one right now, so feel free to skip out. But does anybody have any questions? Yes.
What would you say are the principles to developing interactive graphics?
It's a good question because that's hard. So you can use like Plotly because it works with ggplot. That's what I've been doing just because I'm too lazy to learn D3 right now. I did one D3 thing, and it took me like 2 days to make this little thing that I can drag. And that was great. So that was hard. So what I would recommend is use like Plotly and then investigate all the D3 stuff it spits out. There are cool new packages. There's R2D3, which is like the best R package name. That is like, and they have one of those cool hex stickers that's like a droid. And so use that. It helps. They're trying to make it easier to use kind of the interactive stuff with R graphics. Once upon a time, there was GGViz, but I don't know what I think that's been abandoned at this point.
It's been sunset.
Yeah, so yeah, you just suck it up and learn D3, and then apply all the same principles of contrast, repetition, alignment, proximity to the stuff you do in D3. But yeah.
I think as far as like how to use interactivity, I think there is some like research out there, but I think some of that's still an open question. You know, like how do people interact with interactive visualization, and like what works well, what doesn't work well, and like some of the research that's been done actually shows that static visualizations people understand better from static visualizations than interactive. So sometimes it's like, well, maybe you should just use a static one because people understand better when you're there. You just give them, here's what I want to tell you versus being able to play with it. So some of that's still an open question.
And I think that's, in this research, it's also related to the idea of like the tyranny of choice, where like, so public policy side of me, if you offer a new employee like 50 different healthcare plans when they get employed, they'll just stare at the list and be like, what? Because there's too much to think about. And so if you offer them like 2 or 3 and say there's these other things, people will by nature just choose like the easiest thing. And so with like user interface stuff and this interactive stuff, if you just throw like the Gapminder thing and have like the health and wealth of all 196 countries since 1800 and let somebody play with that, that's cool because it like boosts the data to ink ratio. They can spend a lot of time getting insight, but you have no idea what they're going to learn. They're going to look like at Gabon and follow Gabon over time, and that's the insight they get out of it, which cool. But if you're trying to tell a story about China, they're going to miss that completely. And so when you do the interactive stuff, make sure it's telling a story and helps along with that story rather than just vomiting data at them and letting them play with it.
I have a question. Have you done much with SVG? Do you notice, does Cairo do SVG?
Cairo does SVG,
Okay.
and it embeds fonts in SVG, which is cool.
That is good. That's something I've struggled with. I haven't tried Cairo with SVG. Maybe I will try that.
Yeah.
Yeah.
Do you have any advice for discovering new fonts to use?
Yes.
Free open source that can be used?
Google Fonts. It's the best thing out there. So I like back in my web designer days before I started this PhD stuff, it was like 2006, 2007 when embedding fonts was like impossible on websites, and when you could figure it out, like you were pirating fonts to embed, and it was awful. But starting in like 2010, 2011, Google made this giant repository of fonts. And lots of them are super well done. Lots are like goofy ones that are like a Harry Potter font that just has one weight. But like this right here is Roboto condensed. The whole Roboto family has like 18 or 20 different font families within it, like extra light, light slanted, like all sorts of cool things. And that's great, and it's very well done. Adobe has their own. They have Source Code, or they have Source Sans Pro and Source Serif Pro. IBM just made their own open source, super nice font with like 20 different families. So Google Fonts has that. In the website, there's a section specifically on fonts, and a couple of graphic designers went through like the most popular Google fonts and figured out the best pairings for like sans serif and serif, or script and serif. And so like it's very well like vetted graphic designer chosen fonts.